Okay, so here in problem number 2, we have a horizontal cable, that one, pulls a 200 kilogram cart with a force of 500 newtons. And you really have to label, this is M, given, this is F, given, okay? And the question is, starting from rest, the word rest means VO is equal to 0. So initially it's not moving. VO is equal to 0. How long will it take for the cart to reach a speed of 8 meters per second? And that is going to be your VF. So it's not moving, and then here it's going to be 8 meters per second. And what they want to know is the time it takes for the object to accelerate up to 8 meters per second. So what they're looking for here is time. How long? That means time. And then how far is distance? D in meters. And so it starts here, it ends there. The displacement or the distance, that is what we're looking for in letter B. And again, here we have only one formula. Newton's second law, F is equal to ma. If we rearrange that to solve for A, then we get A is equal to F over M. And that's going to have to be our start, right? Because we don't have the acceleration, but if we're given two of these three, then we can solve for the third. Okay, and so the force is 500 newtons divided by 200 kilograms. And the answer here is going to be 2.5 meters per second squared. So that's going to be your acceleration. Okay, and now we're going to use the definition of acceleration. Acceleration is the change in velocity over time. So that means VF, the final velocity, minus the initial velocity divided by time. Now what we're looking for is time, so we put that over there. This one goes under here, and we start with this equation. T in seconds is equal to VF minus VO over acceleration. This is 0. So the final velocity is 8 meters per second squared divided by the acceleration is 2.5 meters per second squared. Oh, this is meters per second. So cancel units, that cancels with that. One of this cancels with that one, so we're left with that. So it's going to be in seconds, and the answer is 3.2 seconds. So please verify the answers, okay? Letter B. Now we're looking for the distance. We have this equation that we used in kinematics when we have only distance, right? So rearranging this, if we put this over here, it becomes negative, and then we have to divide the whole thing by 2a, so that we'll get d. Okay, so again, d in meters is equal to vf squared minus vo squared divided by 2a. Okay, and what do? This becomes 0, and so 8 meters per second seconds, you square that, you divide it by 2, 4 point squared, and the answer for that is going to be 12.8 meters. Again, please verify. So I hope you got that. And again, you could also opt to use this one. D is equal to VOT plus 1/2 A T squared, because you already, this is 0. This is that one, so you should substitute that here. Now, this is very dangerous because you computed for this one and you computed for that one. So if you make a mistake in either of these, you'll have the wrong answer, right? But that should be what? 2.5 meters per second squared times 3.2 seconds divided by 2. And that should give you the same answer, hopefully.